Hello, I'm Guruprasad Upadhya. So in this lecture, I'm going to discuss the second module of the 18MAT31 in the Fourier series, half-range sine series and cosine series. I'm going to solve or explain some more problems in that. So you already studied half-range sine series and cosine series in lecture 3. I'm going to solve some more problems in sine series and cosine series. Now, you already know what is sine series. If f of x is defined in the interval 0 to L, then the Fourier half range sine series is given by f of x equal to summation bn sin n pi x by L. L means this length of this interval. And how to find bn? That is 2 by L, 0 to L f of x sin n pi x by L dx. Here why we call it as half range? Assume that the given range is half range, and this if f of x is odd function in the interval minus L to L, then the formula becomes 2 times of 1 by L 0 to L f of x sin n pi x by L dx. Therefore, for the half range, the function becomes sine series. Examples: obtain the half range sine series of the following functions. That first one is cos x. F of x is cos x in the interval 0 to pi. How we can express cos x in terms of sin x in the interval 0 to pi? We have L is pi because 0 to L, 0 to pi. Therefore, L is pi. Sin n pi x by L. If L is pi, cancel pi, sin nx. So, f of x becomes bn sin nx. And the bn is 2 by L, 0 to L f of x sin nx dx. Now, L is pi, therefore 2 by pi, 0 to pi, f of x is cos x into sin nx dx. Here, cos x into sin nx, or you can write it as sin nx into cos x. That means sin a cos b formula, that is half sin a plus b plus sin a minus b, and hence it becomes, the 2 cancels, 1 by pi integral 0 to pi sin a plus b nx plus x or n plus 1x plus sin a minus b means nx minus x is nothing but n minus 1x. And you know the integral of sin, that is minus cos n plus 1x by n plus 1. Similarly, sin integral is minus cos n minus 1x divided by n minus 1. Now, carefully substitute these limits. Now, for the upper limit, here x is pi, here x is pi. For the lower limit, cos pi, cos 0 is 1 and cos 0 1. So, for the lower limit, minus of minus, it becomes plus 1 by n plus 1 plus 1 by n minus 1. And hence, it becomes 1 by pi into minus cos n plus 1 pi by n plus 1 minus cos n minus 1 pi by n minus 1 plus 1 by n plus 1 plus 1 by n minus 1. This is lower limit value with minus sign. So, it becomes plus. Now, cos n pi is minus 1 power n. Therefore, cos n plus 1 pi is minus 1 power n plus 1. And here minus 1 power n minus 1. Minus 1 power n minus 1 is nothing but minus 1 power n plus 1, because if you multiply by minus 1 square with the minus 1 power n minus 1, it becomes minus 1 power n plus 1. And hence, if you take minus 1 power n plus 1 is taken outside, it becomes minus of minus 1 power n plus 1, 1 by n plus 1 plus 1 by n minus 1. Now, 1 by n plus 1 plus 1 by n minus 1 is nothing but n minus 1 plus n plus 1 divided by n square minus 1 square by taking common denominator. So, 2n by n square minus 1. Here also 2n by n square minus 1 with minus 1 power n plus 1. Now, 2n by n square minus 1 into 1 by pi. Here 1 minus, this becomes minus 1 power n plus 1. See this. Here if I write this n plus 1 is n minus 1 plus 2, n plus 1 is n minus 1 plus 2, that means minus 1 square is plus 1, therefore minus 1 power n plus 1 is nothing but minus 1 power n minus 1, and hence here it becomes common term, take outside, the remaining term is 2n by n square minus 1 with minus sign. So it becomes 2n by n square minus 1 into pi into 1 minus minus 1 power n plus 1. Now if n is even, then n plus 1 is odd. Minus 1 power odd is minus 1. Minus of minus plus 1. 1 plus 1 is 2. 2 into 2, 4. So 4n by pi into n square minus 1 for even integer n. For odd integer, minus 1 power even is plus 1, because if n is odd, n plus 1 is even. So minus 1 power even is plus 1. 1 minus 1 is 0. For odd integer, this becomes 0. Bn becomes 0. But we are not able to find b1 because denominator also 0. 0 by 0 is not defined. Therefore, find b1 separately. Now b1 is 2 by pi 0 to pi cos x into sin 1x. N is 1. To find b1, put n is 1. 2 cos x sin x is sin 2x. And clearly this integral is 0 because sin of 2 into pi minus x, that is 2 pi minus 2x, that is minus sin 2x. By that property this integral is 0. Or you can integrate this, that is minus cos 2x by 2, upper limit is pi, lower limit is 0, cos 2 pi is 1 and cos 0 is also 1, upper limit minus lower limit becomes 0. Therefore b1 is 0, and hence your f of x becomes, now see this, 4 by pi only for even integer, even b1, b3, b5 everything 0. So for even integer, when n is 2, 2 by 2 square minus 1, 2 divided by 2 square minus 1 is 3. 2 by 3 sin 2x, sin nx, so sin 2x, plus when n is 4, 4 by 16 minus 1 is 15 sin 4x, plus 6 by 36 minus 1 is 35 sin 6x, plus 8 by 63 sin 8x, and so on. So this is required f of x. But what is f of x? Cos x. So we express cos x in the interval 0 to pi in terms of sin. One more example. So it looks very complicated one. F of x is 1 by 4 minus x in the interval 0 to half and x minus 3 by 4 in the interval half to 1. So express this f of x in terms of sine series only. Okay. Now total interval length f of x is defined in the interval 0 to 1. Therefore L is 1 and hence f of x is summation bn sin n pi x by L. L is 1. Therefore it is sin n pi x. And bn is 2 by L 0 to L f of x sin n pi x dx. Now L is 1, so 2 by 1 is 2, 0 to 1 split into two parts, 0 to half, half to 1. In 0 to half, f of x is 1 by 4 minus x into sin n pi x dx, plus from half to 1 the integral here f of x is x minus 3 by 4 into sin n pi x dx. You know how to integrate this one. Here the first function is 1 by 4 minus x minus derivative of the first function is minus 1 minus minus plus 1. Sin n pi x integral is minus cos n pi x by n pi. Again integrate this minus sin n pi x by one more n pi, so n square pi square, and apply the limit from 0 to half. And one more is here this 2 by 1 is 2, that 2 is taken inside here, plus 2 into first function x minus 3 by 4 and then minus derivative of x minus 3 by 4 is 1. Integral of sin is minus cos n pi x by n pi. Again integrate minus sin n pi x by n square pi square. Now see this here. when you apply the upper and lower limit for this function, careful here, when x is half, 1 by 4 minus half is minus 1 by 4. Here is 1 minus. So plus 1 by 4 cos n pi by 2 by n pi. Lower limit is 0 means 1 by 4, here 0, 1 by 4 with minus sign, and lower limit minus sign plus. So 1 by 4 into cos n pi x, x is 0 means cos 0, that is 1 by n pi. And here for the upper limit it is minus sin n pi by 2 by n square pi square. For the lower limit it is 0. And similarly here upper limit 1 means 1 minus 3 by 4 is 1 by 4 with minus sign, minus 1 by 4 cos n pi by n pi. And lower limit half means half minus 3 by 4 is half minus 3 by 4, that is minus 1 by 4 with minus sign plus 1 by 4 cos n pi by 2 by n pi. Here plus 1 by 4. Here 1 by 4 minus half is minus half into minus. See this. Here half, lower limit minus sign is there. See this. Half minus 3 by 4 is minus 1 by 4 with minus sign is plus 1 by 4. But it is for the lower limit, therefore minus 1 by 4. So these two terms, second term of this and first term of this cancels. And here minus minus plus, sin n pi is 0. First term is 0. Minus, lower limit minus sign, sin n pi by 2 by n square pi square. See this. First term 1 by 4th of cos n pi by 2 by n pi. Lower limit value minus minus plus 1 by 4th of 1 by n pi. And next term 1 into minus sin n pi by 2 by n square pi square. And for the lower limit it is minus 1 by 4th of minus 1 power n by n pi. This is upper limit for the second term, that is cos n pi is minus 1 power n. And for the lower limit it is minus 1 by 4 n in the denominator n pi cos n pi by 2 plus minus sin n pi by 2 by n square pi square. And for the lower limit, this is for lower limit, upper limit value of this is 0. Now cancel these two terms. 1 by 4th of cos n pi by 2 by n pi minus 1 by 4th of cos n pi by 2 by n pi. These two terms cancels. And here these two becomes 2 times of minus sin n pi by 2 by n square pi square. And combine these two. 1 by 4 n pi into 1 minus minus 1 power n. Outside 2 is there. Now say this here. Here 4, 2 by 4 is 1 by 2 n pi into 1 minus minus 1 power n. Cancel 2. And then one more term here. These two terms. Minus here 2, here totally 2, minus 4 times of sin n pi by 2 by n square pi square. See, minus minus. So minus 2 times into 2 minus 4 times of sin n pi by 2 by n square pi square. Now how we can simplify this? This is bn value. See, when n is odd, 1 minus minus 1, this becomes 2. 2 by 2 cancels, 1 by n pi minus 4 times of sin n pi by 2, n is odd, sin pi by 2 is 1, sin 3 pi by 2 is minus 1, like that. So minus of minus it becomes plus for 3, and for 5 again plus 1, so it remains minus sign, and hence for odd. For even integer, 1 minus minus 1 power n. For the even integer it becomes plus 1. 1 minus 1 is 0. This part is 0. And for even integer it becomes sin of some k pi, that is 0. Therefore for even integer bn is 0, and hence f of x is, just substitute this bn value, summation bn sin n pi x, and when we expand this, when n is 1 it is 1 by n pi, because this becomes 2, 2 to cancel, 1 by 1 pi, n is 1 minus 4 by, n is 1 means sin pi by 2 is 1, 4 by 1 square is 1 pi square. 4 by pi square sin 1 pi x. When n is 3, for the even integer this becomes 0. When n is 3, again this is 2, 2 cancel, 1 by 3 pi, and this becomes 3 pi by 2 is minus sign, so it becomes plus sign, plus 4 by 3 square pi square sin 3 pi x. When n is 4, again this is plus, and hence this minus remains. Sorry, for n is 5, 5 pi by 2 is nothing but sin pi by 2, and hence it is 1. So this minus remains 1 by 5 pi minus 4 by 5 square pi square sin 5 pi by x. And when n is 7, once again it becomes 1 by 7 pi plus 4 by 7 square pi square sin 7 pi x. Similarly, next term it becomes minus sign. Okay. So this is how we got the half range sine series for the given function. Now, I am going to discuss two more problems in half range cosine series. Suppose f of x is given in the interval 0 to pi, then the Fourier half range cosine series of f of x is a0 by 2 plus summation an cos n pi x by l, and a0 is 2 by l 0 to l f of x dx, an is 2 by l 0 to l f of x cos n pi x by l dx. Okay, take some examples. Obtain the Fourier cosine series for f of x is x square in the interval 0 to pi, and hence deduce that 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square and so on, that is equal to pi square by 12. Okay. Now f of x is a0 by 2 plus summation an cos nx. Why it is cos nx? Because l is pi. Cos n pi x by l is pi, cancel pi, it becomes cos nx. Now a0 is 2 by pi, so 2 by l is pi, 2 by pi, 0 to pi f of x, that is x square dx. Integral of x square is x cube by 3, pi cube by 3, cancel 1 pi, so 2 pi square by 3. This is a0. a0 by 2 becomes pi square by 3 here. Okay. Now an is same logic. So you are integrating x square cos nx dx from 0 to pi. First function is x square and minus derivative of x square is 2x, then plus derivative of 2x is 2. Integral of cos is sin nx by n, again integrate minus cos nx by 1 more n square, again integrate this minus sin nx by 1 more n cube, and limit is from 0 to pi. Sin 0 is 0, sin n pi is 0, therefore these two terms become 0. And here for the upper limit, minus 2 pi into minus means 2 pi cos n pi by n square. For the lower limit, x is 0 means this is 0. Therefore 2 into 2 4 cos n pi by n square into, okay, here x is pi means this pi cancels, so 4 into minus 1 power n by n square. This is an. Now substitute a0 and an value in f of x. So f of x becomes a0 by 2 pi square by 3, because a0 is 2 pi square by 3 divided by 2 means pi square by 3, and 4 minus 4 is taken outside, because when n is 1 it is minus 1, that minus sign is taken outside, by 1 square. So cos x by 1 square. When n is 2 it becomes plus sign, so since minus sign is taken outside, so 4 into minus cos 2x by 2 square plus cos 3x by 3 square minus cos 4x by 4 square and so on. So this is the half range cosine series of the given function x square. Now when x is 0, f of 0 is 0, because you are assuming that this f of x is from minus pi to pi. This is your half range. Therefore f of 0 is 0. 0 equal to pi square by 3 minus 4 into cos 0 is 1, 1 by 1 square minus 1 by 2 square plus 1 by 3 square and so on. And hence pi square by 3 equal to 4 times of 1 by 1 square minus 1 by 2 square and so on. And dividing by 4, so you will get pi square by 12 is nothing but 1 by 1 square minus 1 by 2 square plus 1 by 3 square. Okay. So this is how we can deduce the result. by substituting x equal to 0. Okay, one more example. Obtain the half range cosine series of f of x equal to c minus x. Careful here. C minus x. X is in between 0 to c. Now your L is c, and hence f of x is a naught by 2 plus summation a n cos n pi x by c. A naught is 2 by c, 2 by L is c, 0 to c f of x dx. F of x is c minus x. Integral of c is cx. Integral of x is x square by 2. Limit is from 0 to c. Upper limit c means this becomes c square. Lower limit is 0. Therefore 0. C square minus 0 is c square. And here c square by 2 minus c square by 2. Lower limit 0. C square minus c square by 2 is c square by 2. Cancel 2 and cancel 1 c. Therefore a naught is c. A naught by 2 is c by 2. To find an, same formula, 2 by c f of x cos n pi x by c dx. 2 by c integral f of x, that is c minus cos n pi x by c. Now c minus x, first function, minus derivative of c minus x is minus 1, therefore it becomes plus 1. Integral of cos is sine n pi x by c divided by n pi by c, c goes to numerator. And again integrate this, integral of sine is minus cos n pi x by c, one more n pi by c, so n square pi square by c square, that goes to numerator. Now limit is from 0 to c. For the upper limit, c minus c, that is 0. And for the upper limit, sine 0 is 0. Therefore, first part is 0 for upper and lower limit. And for the second part, cos 0, lower limit is this part is 1. And for the upper limit, it is cos n pi is minus 1 power n. C square by c is c. Here 2c by n square pi square. For the upper limit, it is minus of minus 1 power n. Lower limit, it is minus 1 minus minus plus 1. 1 minus minus 1 power n. Now substitute this a n and a naught value in this formula. That is required half range sine series. 2c by 2, because a naught by 2, a naught is c. Therefore it is c by 2 plus 2c by pi square. 2c by pi square is taken outside. 1 by n square into 1 minus minus 1 power n cos n pi x by c. When n is 1, 1 minus minus 1 is 1 plus 1 is 2. 2 into 2, 4. 4c by pi square cos 1 pi x by c divided by 1 square. When n is 2, this is 0. 1 minus 1, so it is 0. When n is 3, again it is 2. 2 into 2, 4. 4c by pi square is outside. Cos 3 pi x by c by 3 square. For the 5, cos 5 pi x by c by 5 square, and so on. This is required half range cosine series of the function c minus x. Thank you for watching. I hope you got the idea. So I explained some complicated problems of half range sine series and cosine series. Thank you.